Today I'll solve one numerical problem on Venturi method. Here is the problem statement. Water at the rate of 30 liter per second is flowing through a 0.2 meter diameter pipe. A Venturi with a throat diameter is 0.1 is fitted in the pipeline. A differential manometer in the pipeline has an indicator liquid M and the manometer reading is 1.16 meter. Determine the relative density of the manometer liquid. The Venturi coefficient is 0.96 and the density of water is 1000 kg per meter cube. So now we have to find out what will be the rho m. So that is our objective. Now what are the data given? So flow rate is given, Q is equal to 30 liter per second, so that is nothing but 0.03 meter cube per second. Diameter of the pipe D1 is given, so that is 0.2 meter. Diameter of throat is given, D2 is 0.1 meter. Manometer reading is given, that is H is equal to 0.16 meter. Venturi coefficient is given, CD is equal to 0.96. Density of the water means flowing liquid, that is water, the density is given, that is 1000 kg per meter cube. We have to calculate that manometric liquid density. Okay, relative density, so rho m by rho. Now here first we have to apply continuity equation. Q is equal to A1 V1 is equal to A2 V2. A1 is pi by 4 D1 square and A2 is pi by 4 D2 square. A1 we can calculate pi by 4 into 0.2 whole square, so that is 0.0314 meter square, and A2 pi by 4 0.1 whole square, that is 0.00785 meter square. Now V2 Q by A2, so 0.03 by 0.00785, so that is 3.82 meter per second, and V1 Q by A1 0.03 by 0.0314, so that is 0.955 meter per second. So V1 and V2 we got. Now if we apply Bernoulli equation, so PA plus half rho V1 square rho G Z1 is equal to PV half rho B square plus rho G ZV. So here that Venturi meter is in horizontal position, Z is equal to ZV, so P1 minus P2 by rho is equal to V2 square minus V1 square by 2. Now rho is 1000 kg per meter cube, so we know V2 and V1, we plug that V2 and V1 and half is here and rho is 1000, so P1 minus P2 is nothing but 6840. After simplify we will get 6840.1875 Pascal. So now we got that. Now we have to calculate Pn minus P2 through manometer. Now here we just consider the differential manometer, so this portion. So for differential manometer measuring the pressure difference between 2 points P1 and P2, the following relationship hold. So now here we are drawing a one horizontal reference line. Now here that the pressure PA is equal to PV. So now first calculate PA. PA is nothing but that P1 plus that total height, total height into rho into G, means the pressure due to this liquid height, so y plus h rho into G. So now if I simplify, P1 plus y into rho into G plus h into rho into G, PV will be here, so P2 plus, because of the pressure because of this side and because of this side, so y into rho into G plus h into rho m into G. So PA is equal to PV at the reference line. So now P1 plus y rho G plus h rho, here G is missing, G, P2 plus y rho G plus h rho m into G. So here this and this will be cancel out. So finally, so we'll have, so this one, so G is missing here. Okay, so this will cancel out. So P1 minus P2, so h rho G common, so Pm minus rho. So now we got earlier, so that P1 minus P2 is 6840. Now we can write h into G into rho m minus rho. So this, so h is 1.16 and G is 9.81 and rho is 1000. So now rho m minus 1000, so that 6840.1875 divided by 1 into 9.8, so that will be 601 0.9. so rho m will be 601/09 plus 1000, so 160109. so that is the density of the manometric liquid. Now relative density of the liquid will be relative density rho m by rho water, so 160109 by 1000, so that will be 1.601. so that is the relative density of the liquid M. That's it. Thank you.